start. In the previous assignment, the first question was how many lines can pass through one given point and two given points. Okay, so the answer is through one given point you can draw infinite number of lines, and through two given points only one straight line can be drawn, but any number of curved lines can be drawn. I have shown in the figure here. So I have one point. Now I have drawn one line, two lines, three lines, four lines, and so on. So through one single point, infinite number of lines. Whenever here we mean straight lines, children. So unless we specify it as curved lines, we always mean lines mean straight lines. Okay. Now with two given points, let's see how many we can draw. Now I have two given points. So through them, we can draw only one single straight line, but we can draw any number of curved lines as shown. Is that clear, children? So through one single point, infinite number of lines can be drawn. Through 2 points, only one single straight line can be drawn, but infinite curved lines can be drawn. Up and down you can draw. The next question is, on a straight line AB, we have a straight line AB, a point P lies on line AB. So the point P is not specified where it lies on the line AB. You can draw it anywhere, you can mark it anywhere. It's not mentioned exactly where it is. So it can be in the center or on either side. Is that clear, children? Third one. So you have a line L. On line L, we have 2 points S and R, but not C. So that was the question, if you remember. So on line L, we have points S and R, but not C. The next one is, draw a ray OA. Starting initial point of the ray is O, and the ray passes through A. So the ray is OA, ray OA. Okay. The next one is, we have a line segment GH and M lies on the line segment GH. Next one was the sixth main to state true or false from page 75. I told you all to, since you all have the textbooks, that main, sixth main has true or false. You had to just read the statements by looking at the given straight line there. Some points are also marked on that. So the straight line with 5 points, I think. So they are point Q, M, O, N and P. Now let's see what the statements are and whether they are true or false. Okay. The first statement is, on line MN, so I told you a line has infinite number of points. If it is a straight line, it has infinite number of collinear points. Now here on this line, Q, M, O, N, P are collinear. Okay. Now he says Q, M, O, N, P are points on the line MN. It's true. Is it not? All these points are collinear and they all are lying on the line MN. Next, MON points are the points on the line segment MN. So where is the line segment starting at M and the end point is N? On that line segment MN, we have M, O and N as the points, which is true. So the first statement is true. Second statement is also true. The third one, for the line segment MN, the end points are M and N. True, is it not? On that line segment MN, if we take the line segment on that line, M and N are 2 points. So the segment lies between M and N for line segment MN. So M and N are the end points. O and N are end points of line segments OP. If you take the line segment starting at point O and ending at point P, he says O and N are the endpoints, which is false because N lies somewhere on the line segment OP. Okay. M is one of the endpoints of line segment QO. Now where is Q? Try to locate Q and try to locate O. The line segment is QO. Okay. He says M is one of the endpoints. Again false, because M is in between Q and O, somewhere in between. So it's a false statement. Go to the next one. M is point on ray OP. So ray OP starts at O and moves through P. Okay. He says M is a point on OP, which is false. M means beyond, that is it doesn't lie on ray OP. So it's a false statement. Next one. Ray OP is different from ray QP. You can see Q, the ray QP starts at Q and goes through P, and ray OP is part of that ray QP. So he says they are different. It's false statement. Ray OP is same as ray OM. See, OP is moving towards the right. Ray OP starts at O, moves to the right. But ray OM starts at O, moves to your left. So they are not one and the same. They are in fact in opposite directions. Next one. Ray OM is not opposite to ray OP. He says ray OM is not opposite to ray OP. In fact, they are opposite like we discussed. So it's also a false statement. Next one. O is not an initial point of OP. Okay. He says OP, if you consider it as line or line segment, he says O is not an initial point. It is an initial point. So it's a false statement. Next one. N is the initial point of both NP and NM. If you consider ray NP, N is the initial point. If you consider ray NM, N is the initial point. So it's a true statement. Did you all understand, children? So I hope the assignment is clear. In case you have any doubts, please watch this slide once again and make the corrections wherever you've gone wrong. So next, let's move on with the next part. Now, let's start the next session with curves. What is a curve? Now, many times, children, you will be drawing some random designs without even lifting your pencil. You don't give much thought to that design. It's not intentional, but something your mind may be thinking. You may be thinking something, but your hand may be doing something. So this way of abstract patterns is called doodling. Okay. So most often when you're doodling, the patterns that you get are called curves. So what is a curve? Anything that is not straight is called a curve, and mostly when you're doodling, you get patterns which are curves. They are not intentional, so you get random designs which are mostly curves. Okay, so to draw lines, patterns, etc. without thinking is called doodling. So now let us see what patterns we get when we do this. So you can see on your screen, these designs are not done without any thinking. It is just random designs, is it not? So some are simple, some are crossed. So such patterns are called curves. Now in curves, you have open curves and closed curves, or open figures and closed figures. Now let's see what open figures are and then what closed figures are. Now what do you think open figures are? Have you drawn any time open figures? Now on the screen you can see the first one is open. What do we mean? We have started the pattern, but we have not come back to the same position where we started. Such figures are called open figures. So let's see some designs of open figures. Okay. Now you can see. So you can even start drawing in your books whatever you feel like drawing. Okay. So draw about 4 open figures and let's say 4 closed figures. Now you can see the difference. In the first case, open figures are open. That means we have not come back to the position where we have started the curve or a line. That means it's not closed, it is open at some point or the other. Such figures are called open figures. Closed figures are we start at a point and our pen or pencil comes back to that point where we have started. That way we are closing the figure. So it may be a curve or it may be a figure with line segments also, as you can see on the screen. Okay, these are closed figures. Now let us see what the position of points in a closed figure are. I have taken an example of a circle which is a closed figure. Now in this closed figure we have three parts. What are the three parts? It is interior of the curve, that is inside of the curve, boundary of the curve, that is on the curve, that is on the perimeter or circumference. Okay. Now we also have points outside the curve. Now what do we mean by boundary? Whenever you enter your house, you cross a threshold or you cross a compound or a gate. That is called boundary. So we are going to discuss about position of points in a figure. What I am showing is a closed curve. The same thing can be shown even in figure which contains line segments. Okay. Now let's see what the points inside of the curve are. Now all of you please draw one curve. It need not be circle. If you want to draw a circle, that's fine. If not, also that's fine. You can draw a closed figure. And mark 2 or 3 points inside the curve and mark 2 points on the curve, that is on the boundary, and draw few points, locate few points outside of the curve. Okay. Now let's see, let's label. As you all know, we have discussed earlier that any point, any line segment, any line or ray should always be labeled in mathematics. Is it not? Then only we can point out at that particular figure. Okay. Now the inside of the points I have named as A, R. On the boundary you have X, Y, and then you have outside, that is exterior points, as P, Q, Z. You can also label the points that you have drawn in your figure. Okay. And let's write down all the points. So interior points, that is all the points lying inside the curve. This is a closed curve, children. It's a closed figure. This figure is made up of a curve. So where it has started, the initial point and the ending point are the same. That's why it's called a closed figure. So interior points are all the points lying inside the figure. What are they? They are A, that is point A, and point R. So what are the points lying exterior of the figure? They are, can you locate? P, point Q, and point Z. Is it not? Now on the boundary, what are they? They are point X and point Y. Did you all understand? So a closed figure, whether it is a closed figure made up of curve or line segments, it has three parts. What are the three parts? Let's again repeat. Interior of the figure, interior of the figure, boundary of the figure, and exterior of the figure. Here, since I've used curve, a closed curve, we have mentioned it as interior of the curve, boundary of the curve, and exterior of the curve. So the points interior, inside the boundary, that is inside region, is you have 2 points, they are A and R. On the boundary you have X and Y, and exterior points are P, Q, and Z. These exterior points lie outside the boundary, children. Okay, let's move on. Now, the interior of a closed curve along with its boundary is called area or region. All of you know what area is? The region inside the boundary is called area. The region inside the boundary is called area. The boundary itself is called perimeter, or if it is a circle, it's called circumference. Okay, children? So, next is, let's see what polygons are. Now, in the previous figure, the closed curve was made up of a curve and not a straight line. Now, let's see what a polygon is. Now, you consider the following figure. In that figure, let's see how many line segments are there, whether it is an open or closed figure, and how many line segments are required to call it a closed figure. Okay, let's see. Now, yes, on your screen you can see two line segments. Do you all agree that there are two line segments? Yes, please. They are line segments because they have a starting and an ending point. Only if there are arrows, then it can be classified as ray or line. Now, these two line segments are meeting at one point. Okay, all of you know what the point is. It's called a vertex. Now, can you call this a closed figure? Can you? You cannot, is it not? Because now in this figure we have two line segments, so it is an open figure. Now, to call this figure closed figure, how many line segments are required? At least we need one line segment to close it. Okay, let's see. Now, there are two line segments. The figure is an open figure. One more line segment is required to call it a closed figure. Now, can you see the figure and name it as? We name it as a closed figure because it contains three line segments, 2 plus 1, 3. Now it's a closed figure. Such figures, plain figures, which are closed with at least 3 line segments are called polygons. So what is a polygon? It is a simple closed figure containing or bounded by or made up of at least 3 line segments. Okay, so that is a polygon. So what is a polygon? A polygon is a closed figure made up of at least 3 line segments. Poly means many. Poly means many. Polygons means many side, figure with many sides. So, to call it a closed figure, we need 3 line segments is what we have studied now. So, after connecting with the third line segment, now you can see it has become a closed figure. So, we define a polygon as a polygon is a closed plane figure bounded by at least 3 line segments. Now children, can you tell me what the figure is on your screen? All of you know what it is. It is a polygon with 3 sides called triangle. Tri means 3. Tri means 3. So this polygon is called a triangle. Likewise, if 4 sides we have a different name, 5 sides polygon we have a different name. Let's see what they are. Now, polygons are entirely made up of line segments. Okay, they are made up of simple line segments which do not cross over, children. Okay, they are plain, simple, closed figures like you can see on the screen. The first polygon has got 3 sides. The next one has got 4 sides. So the polygon with the least number of, at least if you have 3 sides, you can call it a polygon. Okay. The next one is 4-sided one. The third one is also 4-sided. They are all made up of simple line segments. Do you all agree? All these polygons are made up of simple line segments. The least one is 3 line segments. So, can you name them? What is the first one? A triangle. What is the next one? A quadrilateral. Children, you all remember what a quadrilateral is? A figure with 4 sides. Okay. The next one is also a quadrilateral. The last one is, just check how many sides are there. Count and tell me how many are there. It has got 10 sides, so it is called a decagon. So all these are examples for polygons. Okay. Now the above figures are called simple polygons. Now you have an activity. Draw polygons with 3 sides, 4, 5, 6, 7 and 8 sides and name them. Can you do that? You have drawn in your 5th standard. So take a pencil, sharp pencil and a ruler and start drawing polygons with minimum 3 sides, then 4, then 5, 6, 7 and 8 sides. Can you do that, children? Okay. So the first one is 3-sided polygon. The next one is 4-sided polygon. Then 5 sides, 6, 7 and 8 sides. Have you all drawn these figures? Now let's name them. What is the first one called? It's a triangle. Is it not? You all agree it's a triangle? The next one is called a quadrilateral, children. Though it looks like a square, please do not call it square unless it is the sides are measurements are mentioned or some mark should be there to show that they are all equal sides. So otherwise we cannot take it for granted. So we call it quadrilateral because it has got 4 sides. Quadri means 4. Lateral means sides. 4 sides. So 4-sided polygon is called quadrilateral. 5-sided polygon is called, yes, can you tell me? It's called a pentagon, is it not? Then 6-sided polygon is called hexagon. What is 7-sided polygon called? It's called heptagon. And 8-sided polygon is called octagon. Okay, so copy down all these names along with the figures. So each one, you see the 3-sided figure is called triangle, 4-sided figure is quadrilateral, 5-sided figure is pentagon, then 6 sides is hexagon, 7 is heptagon and 8 is octagon. Okay, children. Now let us see what sides, vertices and diagonals of a polygon are. Now consider this figure. How many sides are there in this figure? Yes? Can you look at the picture and say how many sides, that means how many line segments it's made up of? So all of you can clearly see it's made up of 4 different sides. So all these 4 sides, they have formed a polygon, 4-sided polygon. So we'll call it a quadrilateral. Though it looks like a parallelogram, like I said, in geometry, unless there is some markings or measurements, we cannot take it for granted and call it parallelogram and square. Okay, so I'm just calling it quadrilateral. So this quadrilateral has got 4 sides. Okay, now first to name all these sides, what do we need? You all know what we need. We need the names of the vertices. Okay, we have to label the vertices. Okay, so all of you draw this figure. Any quadrilateral, children, with 4 sides, any quadrilateral, and name the vertices as PQRS. Now, the sides are, can you label the sides? Line segment PQ, QR, RS and PS. Do you agree with me? So in this quadrilateral, the vertices are P, Q, R and S. What are the sides? They are PQ, QR, RS and PS. Okay, children. Now let's see what the diagonals are. Now, What is a diagonal? A diagonal is a line segment which joins the opposite vertices of a figure, of a polygon. Okay, now if I join the opposite vertices, that is P and R, with a straight line segment, that is line segment, I get one diagonal. Likewise, how many diagonals are there in this figure? Can you all guess? Yes, children, how many diagonals are there in this figure? There are 1 and 2. The first one is P and R. Connect P and R with a line segment, you get one diagonal. The other diagonal is connect Q, that is vertex Q with vertex S, that is opposite vertices. Then you get one more diagonal. So this figure, a quadrilateral, has got two diagonals. Is that clear? So line segments PR and QS are the diagonals of this quadrilateral. So what is a diagonal? A diagonal is a line segment joining the opposite two vertices of a polygon. So what's a diagonal? Please repeat. The line segment joining the opposite two vertices of a polygon is called a diagonal. Clear, children? Next. Let us see what adjacent sides of a polygon are. Now all of you know what a polygon is now. All of you know that, children, what a polygon is. A polygon is a closed plane figure bounded by at least 3 line segments. And just now you learned what vertices are, what sides are, and what diagonals are. Now let us see what adjacent sides of a polygon are. Okay? Now, any two sides with a common end point are called adjacent sides. Now, imagine you are sitting in a classroom. The next class, the children sitting in the next class, the next room, you share one wall with that room. Do you agree? Suppose 6th A children are sitting in one room. The other children are in the next room, the very next room, separated by a wall. So, between the two rooms, what is common? The common is the wall. So, we say these two rooms are adjacent to each other. That means they share one common wall. Likewise, any two sides with common end point are called adjacent sides. Now, let us see. Now consider the given figure which closely resembles a square. Why am I not calling it a square? Though it looks exactly like a square, unless in geometry, please remember, unless the sides are specified what the measurements are, or unless they are all marked with a single stroke or double stroke, you cannot call it a square. But we take it for granted it's a quadrilateral. Is it not? It's a polygon made up of 4 line segments. Now, label this figure. Always remember, children, whatever figure you draw, you have to label the vertices. Only then you can label the sides or adjacent sides or opposite sides or diagonals. Okay. So, the sides are AB, BC, CD and AD. Do you agree? The sides are AB, BC, CD and AD. These are the sides of the quadrilateral. Now, what are the opposite vertices, children? Do you all agree that A and C are opposite vertices? A is a vertex, C is a vertex. They are opposite to each other. They are facing. Is it not? They are not next to each other. They are opposite to each other. Likewise, B and D are opposite vertices. Do you agree? Okay. Now, what are opposite sides? In your classroom, you can imagine, or in a room that you are sitting, which are the opposite sides? The walls facing each other are opposite to each other. Is it not? So, here in this figure, opposite sides are AB and DC. Do you agree? The opposite sides are AB and DC. Likewise, which is the other pair of opposite sides? It is AD and BC. So AB is opposite to DC. Do you all agree? And AD is opposite to BC. Then what are adjacent sides? Just like how we discussed, if two sides have a common vertex or a common end point, then such sides are called adjacent sides. Just now we gave one example. What are adjacent rooms? The rooms which have a common wall in between them are called adjacent rooms. Okay, so in this figure, let us name all the adjacent sides. That means they are in pairs, is it not? So AB, BC are adjacent sides. AB and BC are adjacent sides. So what is the common end point that we spoke about? Which is the common point? Which is the common vertex that they are sharing? They are sharing B, is it not? So AB and BC are adjacent to each other. So we got one pair of adjacent sides. Likewise, let us see many more pairs are there. So the next adjacent sides are BC and CD. If BC and CD are to be called as adjacent sides, they should be sharing something. What are they sharing? They are sharing the vertex C. So BC and CD are adjacent to each other. That is the second pair. What is the third pair? Go in an order so you won't miss out on the adjacent sides. Okay, children? So the next pair is CD and DA. CD and DA. So what do they share? They share the vertex D. So that is the third pair of adjacent sides. Which is the last pair? It is AD and AB or DA and AB. So these two sides share the common vertex A. So you have four pairs, AB and BC. B is common vertex. BC and CD. C is the common vertex. CD and DA. D is the common vertex. AB and AD. A is the common vertex. Do you all agree, children? Okay. So let's move on to the next one. Let's see what this activity is. Identify simple polygons from the following figures and draw them in your notebooks. Okay? Let's see what the figures are. Now, as the figures are appearing on your screen, copy them. And out of these figures, your activity is to draw them in your notebooks. That means you have to identify simple polygons from this figure and draw them in your notebooks. Okay. Now, we just now learned what a polygon is. A polygon, again, children please repeat. A polygon is a closed plane figure which consists of at least 3 line segments. It is bounded by at least 3 line segments. So that's a polygon. Now, and we also discussed that a simple polygon is a polygon which do not have any crossed lines. Okay. Now, out of these 5, please identify simple polygons. Can you? Okay. The first, the second, and the fifth one are simple polygons. Do you agree? They are made up of line segments. Okay. Now, in the next activity, look at the figure that's appearing on the screen. How many sides are there? Please count and tell me how many sides are there. There are 6 sides, is it not? So, these 6 sides, they form a polygon. And what is the special name for that polygon? It is a hexagon. Hexagon means a polygon made up of 6 sides. Okay. Now, Your activity is, now what are these lines that are being drawn on the figure? These are all called diagonals, is it not? What is the diagonal? The line joining the opposite vertices of a polygon are diagonals. So in this hexagon we have three line segments. Those line segments are called the lines that are joining the opposite vertices, they are called diagonals. So we have three diagonals in a hexagon. Now let us name all these points. Okay, there are 6 vertices. That's why we got 6 sides. So it's a 6-sided polygon called hexagon. Now, in the adjacent figure, name the opposite sides. Your activity is, in this figure, name the opposite sides and adjacent sides. Okay, in the previous figure, in the previous activity, it was a quadrilateral. So you got opposite sides and adjacent sides. You all labeled them. Okay, now in this figure, which has got 6 sides, let us name all the opposite sides and all the adjacent sides. Okay, can you start? Okay. The first one is, anyway, any order you can go, children. So, DI and FG are opposite sides. Am I right? Do you all agree with me that DI and FG are opposite to each other? Yes? So, one pair of opposite sides I got. The next one, DE and HG. DE is a line segment or a side and HG is a line segment or a side. Likewise, EF and IH are opposite to each other. So we have 3 pairs of opposite sides in this figure. Again, DE and GH are opposite sides. DI and FG opposite. EF and HI are opposite sides. Okay, so 3 pairs of opposite sides we got. Let us see how many adjacent sides we'll get. We are going to get many, is it not? Let us name a few. So now you all know that adjacent sides share one common vertex, is it not? Common point. So let us see, let us start labeling them. So EF and FG, please follow as I am pointing out. Try to identify that line segment. EF, FG. Do you agree that they are adjacent sides? Yes? Yes, they are, because F is a common point. F is a common vertex. So I can even label it as FE and FG. If you find that easy, please label it as FE, FG. F is common. So that is one pair of adjacent side. Then we have GF and GH. FG and GH can be also named as GF and GH. So likewise we have many adjacent sides. So write down EF and FG, FG and GH, GH and HI, HI and ID, ID and DE, DE and EF are all adjacent sides, children. I hope all of you understood what simple polygons are and what opposite sides and adjacent sides of a polygon are. There is a difference between opposite and adjacent. Adjacent means lying next to each other with something common. Adjacent room is 2 rooms with a common wall. Adjacent sides of a figure are 2 sides with a common vertex. I hope till here it's clear. Okay. Now, pair of lines. The next part of this lesson, basic geometrical ideas, is pair of lines. That means if 2 lines are there, looking at the pattern, trying to understand, looking at the property, learning the property, let us see what type of lines they are called. In this chapter, we are going to learn 2 types of pair of lines, children. Okay? They are intersecting lines and parallel lines. They are intersecting lines and parallel lines. The moment I say intersecting lines, what comes to your mind? Two crossroads, is it not? Two roads crossing each other. Let us say 15th cross and 4th main, or 13th cross and 6th main. They cross each other at one single point, is it not? Such lines are called intersecting lines. Okay? Now, when two or more lines cross each other at a common point, they are called intersecting lines, and the example that I have given is two roads crossing each other. You can do a simple activity. Take two rulers in your hand or two pencils and cross them. Arrange them in such a manner that they cross each other at a point. Such lines are called intersecting lines. These lines are crossing each other at a common point, a single point. Such lines are called intersecting lines. So, these lines which cross each other are known as intersecting lines. Okay? You can see and draw these intersecting lines, children. Did you understand? So, we have three pairs of intersecting lines. The first one, the second one, and the third. All the three figures drawn are called intersecting lines. As you all can see, these lines cross each other at one single point. Clear? Next one, parallel lines. Now, whenever we talk about parallel lines, what comes to your mind? Yes, children, the most common and very well known parallel lines are the tracks, the railway track. Is it not? Have you seen a railway track? I'm sure all of you have seen. So how are they? The tracks are such that they never meet each other even if you extend it indefinitely. One more simple example is the blackboard in your class has four sides, is it not? It's a rectangle. Now, two opposite sides of that rectangle never meet each other. Okay, so these are called parallel lines. What about the bars on a window? All these bars, the iron bars, are parallel to each other. They do not cross each other even if you go on extending. Such lines which do not meet each other even when extended indefinitely are called parallel lines. In other words, children, the distance between these two lines is constant throughout. That means the width between these two parallel lines is common. Okay, such lines are called parallel lines. Okay, now I have drawn two parallel lines. Please, you also draw. Like I said, it can be in the lines can be in any direction. I have drawn two horizontal lines which are parallel to each other. Line L, line M. You may be asking, so this line should have 2 points. Okay, but when we use a small letter, we can represent a line with a single alphabet. Okay, so line L and line M, you can see, are parallel to each other. How to write it? How to represent it? Line L is parallel to M. L is parallel to M. The symbol for parallel you all can see. How do you read this? L is parallel to M. Okay. Examples: railway track, opposite sides of a blackboard, all the lines in a rule notebook. In your rule notebook, children, your arithmetic book or science classwork, how are all the lines? They're all parallel to each other. That means between the two lines, the distance is constant throughout. Such lines are called parallel lines. Opposite sides of your writing table also can be called as parallel lines. So what are parallel lines? If two lines do not meet each other, even when extended indefinitely, such lines are called parallel lines. Okay, please draw parallel lines. at least 2 or 3 pairs of parallel lines in different direction to understand. Okay. Now, activity. Identify the parallel lines and intersecting lines from the following figures. Okay. Now, 4 figures are on your screen. Identify which lines are parallel and which lines are intersecting. Okay, that's the activity for you. Can you identify? What about the first figure? In the first figure, you have all the horizontal lines. It looks like a ladder, is it not? You can consider this as a ladder. The horizontal lines are all parallel to each other and the vertical lines are all parallel to each other. So, this example you can call them both parallel and intersecting lines. So, horizontal lines are all parallel to each other, vertical lines are parallel to each other, but the horizontal and vertical lines together form intersecting lines. Likewise, a railway track, you can see how the track is, all the two vertical lines on which the train moves, they are parallel to each other. Is it not? They should be. Otherwise, imagine what happens if the lines are not parallel to each other. Okay, you may ask, sometimes the tracks cross over each other. Yes, one pair crosses over the other, but the lines in that pair do not cross each other. You understood the difference, children? One pair can cross the other pair, but in one pair, two lines do not cross each other. Okay, so here also in the second example, you have vertical lines and you have even the horizontal lines which are parallel to each other. Third example is purely parallel lines. Fourth example is intersecting lines. Okay, so name them. Answers are: all the horizontal lines are parallel to one another and vertical lines are parallel to each other. So vertical lines intersect the horizontal lines. The next one is, it's a railway track. Again, example for parallel lines. Third one is an example for parallel lines. And the fourth example is intersecting lines, children. Okay, I hope you all understood the difference between parallel lines and intersecting lines. Okay, again recall, parallel lines are lines which do not cross each other even when extended indefinitely. Intersecting lines are lines that cross each other at a single point. Now let's see what your assignment is. Draw two rough diagrams, each to illustrate open figures and closed figures. You know what open figures are and what closed figures are. Please correct it as CLOSED, closed figures. Okay, children, that's your first assignment. The next one, draw any polygon and shade its interior. You can draw any polygon, you know. The least one is triangle, three-sided. So you can draw any polygon, triangle, quadrilateral, hexagon, heptagon, pentagon, anything, and shade its interior. You may use any color. Next one, in the given figure, name all the sides, opposite sides, two pairs of adjacent sides and diagonals. Okay, now the figure is on your screen. Name all the sides, name opposite sides and two pairs of adjacent sides and name all the diagonals. So first draw the figure, mark all the vertices and answer all the given questions. Now, illustrate if possible each one of the following with a rough figure. What we mean is, use figures to represent if possible, children. Illustrate if possible each one of the following with a rough diagram: a closed curve that is not a polygon, an open curve that is made up of only line segments, and a polygon with two sides. Think properly and answer. Okay, children. So I hope you've understood today's lesson. So wish you all the best. Take care, children. Be happy.